Hey guys, today we're going to talk about lesson 4.4, and that is using corresponding parts of congruent triangles. This is the start of the second half of chapter 4. In the first half, we spent a lot of time talking about congruency of triangles and working with some proofs. So here we're going to continue our study on proofs, and we're going to add a fourth phase to our three-phase answer key. Okay, so you may have saw in one of the previous quizzes this combination of letters CPCTC, and what that stands for is corresponding parts of congruent triangles are congruent. And how we're going to use that in our proofs is by proving a triangle is congruent. Once we prove a triangle is congruent, we can then pull out those congruent parts that we discussed in 4.1, those 6 pieces of information from our congruent statement. Okay? So here's our proofs answer key that we've been working with throughout the year. And you can see we have the first 3 phases: label the given, use the given in the picture, and find the 3. And we're going to add a 4th phase. So if the prove, and we'll get to this more into an example today, but if the prove has an angle equals an angle or an angle equals a side, then we will be using CPCTC, or corresponding parts of congruent triangles are congruent. Okay? So before we get into an example, we're going to just review a proof really quick. We're going to go through our process. So we're going to label the given. We're going to write that in our 2 columns. So we have BA is congruent to DA. We also have CA being congruent to EA. And our reason there would be given. So we have BA is congruent to DA, CA and EA are congruent. All right. Moving into our second phase, we would use any key terms up here in the given, which I don't see any key terms of midpoint, bisect, perpendicular, parallel. So now we move into the picture. And in our picture, we do have this hourglass shape where we can use vertical angles. So we're going to write down that angle A, which would be BAC, is congruent to angle DAE. By the vertical angles theorem. And that leads us into phase 3, where we take our information. We have our 3 pieces. You can see that in the proof, in the 2 columns, or in the picture. And we have enough information to prove that the 2 triangles triangle CAB is congruent to triangle EAD. And that is by side, angle, side there. Now, here's where the 4th phase comes into play. Sometimes we will see that our proof will not be a triangle is equal to triangle. So I'm going to sort of just erase this and add, what if our proof said angle C is congruent to angle E. So what if this was now our proof instead of the two triangles? All right. So think back to 4.1 where we were listing all the corresponding parts, and so far in our proof, we have proved these three pieces of information. Well, we could also say that we have CB is congruent to ED. So that's one of the sides that we're missing. And from our congruent statement, we can also say that angle C is congruent to angle E, and angle B is congruent to angle D. So because we have proved triangles are congruent through side angle side, we can also say that not only the three pieces of information that we proved were true, all six pieces of information are true. So we are now able to take this information out, angle C is equal to angle E, and put that in our proof. And our reason here will be CPCTC. Those corresponding parts of congruent triangles are congruent. So here we're just adding an additional phase to our three-phase process. Okay? All right. So we're going to look at another example. So one thing I do notice is that our proof is a side KB is congruent to side CA. So because this is not a triangle is equal to a triangle, all right, this is not a triangle is equal to a triangle, we know that we're going to be using our CPCTC, or corresponding parts. All right, so we're going to go through our four phases now. And I'm going to start out by writing our given. KC is parallel to BA. And KB is parallel to CA. So we're going to put our little arrows in here. All right, now we move into phase two, where we're using the given. We're going to be using our parallel here. So with parallel, we oftentimes use alternate interior or corresponding. And here with our parallel lines, we're going to end up using alternate interior. So there's our parallel lines and our transversal, where we have this angle in the top right is congruent to this angle in the bottom left. And then we also have a second pair with a transversal, where we can prove another set of angles is also congruent through alternate interior. Okay, so our step two, we're going to show that those angles are congruent in our two columns. So I want to start out here with the angles of one tick mark. I have KCB. Angle KCB is congruent to ABC. And then we also are going to look at the angles of two ticks, which would be KBC. So the letters are going to switch up a little bit. Is congruent to ACB. And our reasoning was because of those parallel lines, we have alternate interior angles. All right, moving into our third phase, we look at our picture here and we see that we do have these stacked triangles where they share a side. And so that would be reflexive. We would write BC is congruent to itself BC due to reflexive. And then we're into phase 3. Now, before we get to our proof, we must say that these triangles are congruent. So we got to prove the triangles are congruent first before we use CPCTC. So we'll call this triangle 1 here. We have KBC, triangle KBC is congruent to our second triangle, which would be ACB. And that is through our angle side angle shortcut. We have two angles and an included side. So I have ASA here. And now we can say that side KB and AC are indeed congruent. So KB is congruent to CA because of our corresponding parts of congruent triangles are congruent. All right, so not much has changed in our proof process. The only change is we've added that extra phase, okay? All right, guys, I want you to take a look at the practice. If you have any questions, get in touch with me and complete the quizzes when it's assigned.